Alright, welcome back to the Everything is Swift, and let's solve the 2D Leetcode problem. As always, I got missed the yesterday Leetcode problem and now trying to catch up with the 2D Leetcode problem. So 2D Leetcode problem is delete the columns and make sorted. So we are given an array of n string, including the strings in each index of the same length. So all the strings inside the arrays have the same length, and the string can be arranged such that there is one on each line making a grid. For example, ABC, BCE, CEAE. So that is according to their given string. And then what we want to do is we want to delete the column that is not sorted lexicographically. What do you mean by lexicographically? So we want to make the string sorted vertically. That means if we read the first zero index column, that will be ABC. So that means technically that is sorted in zero index. What about the second contents, BCA? So that is not sorted. And then the last CEE, that is also sorted. So we have to return the number of columns that we will delete. So okay, in that case, we will delete the column 1, and then the answer is 1. The same for the example 2. Let's check together. And then we have like CBA, DAF, GHI. So CDG, that is sorted. AFI, that is sorted. BAH, since A should come before B, so the middle column index 1 is not sorted. So we're gonna pop it out and then return the output as a 1. And then for the example 2, we only give like AB since it is sorted lexicographically, so we just return the output as 0. And then yeah, I think that's pretty much for the example. We don't need to go through till the example 3 since it is a similar one. So I was thinking of like how about we count the row? That would be the each row counts is a string.count, like how many rows that we have. That could be like 2, and then we need to count the how many column we could have. Let's call like column will be the string of 0.count. So we can mark it as an index 0 because pretty sure like n will be at least 1. So that's why I have a confidence to write like index 0.count as a row. And then since it is a Swift, we're gonna take that. Let's say we have a string value something like this. Let's call like my string, and then we have value like Swift. Only in our programming Swift language, we're gonna take it like my string dot 0. That is not possible. So what I'm gonna do now in here is I will use the same variable name, and then I'm gonna change that into the each array into the string. So that means that I'm technically changing everything into the character string array. So okay, we will need like, okay, how about we go through like let's call like row. Alright, let's call column C in 0 through our column. And then for row in 0 through row minus 1. The reason why I have to detect the minus 1 is I don't want to go through till the end of the rows. So yeah. And then what I can do in here is I can simply get a character, which is a string of rows and column, and then I will calculate the next character. That will be the row plus 1 and column. So by comparing these two, what I can do is if character is greater than the next character, that means it is technically something wrong, and then we will need the one variable in here like r reset 0, I'm gonna pop it out like reset plus equal to 1, and then break from here, and then just turn the reset. Yeah, I think that would be the O of row and column for the space and time complexity, if I'm not wrong. Let's check together. Yep, that's exactly what I was expecting. Yep, that's all for it, and then see you in the next one. Bye.